This conference will now be recorded.
Okay. Okay. So we were at performance testing walkthrough. Okay. So we have discussed performance life cycle when we have discussed the performance testing process and the methodology that we are going to follow in a project. Then we have looked at the trigger points that which one should be watchful for any project, which can help us to identify the okay, this project needs performance testing. Okay. Now will be any doubts in this one? Anyone before we move forward? Okay. Now, next thing, we'll be quantifying it in terms of let's say I said, okay, there will be a increase in the user base. So what is the number? Or I said, what is the significant change in code volume? So we'll be quantifying it to understand in a much better way. So that tomorrow, if you tell somebody or in your project also, you say, okay, this you ask this question that, sir, is there an increase in the user base? They say yes. So how do you decide that, okay, 5 users, 6 users, 7 user, what will be the number that should help you to identify, okay, this user base needs to be, if there is this much amount of increase is there, then we should definitely go ahead with the performance testing. Okay. So uh, on the first point, if you see total number of users and concurrent users, so already told what is the difference between a concurrent user and a simultaneous user. So concurrent users are basically all the users. Let's say I have there are
And
10
you are
users
not
live on the
sharing your
application.
screen.
You're saying something?
You are not sharing your screen.
Okay, my bad. Sorry. Thank you. Okay, now you can see it, right?
Yeah.
Okay, cool. So, okay, so we were at this page. Yeah. So I was discussing that how do you quantify the numbers? So the first thing when we say that okay, there's an increase in the user base, then we should go ahead and do the performance testing. So what is the user base? Okay, so there are two types of users: concurrent user and simultaneous user. Now, what is the difference between that? Anyone wants to tell? I already told this in the last class. Okay. The simplest way to understand this is that let's say if I say that there are 10 concurrent users on Amazon. Okay, that means those 10 users are live on the application. They are doing something on the website. Okay, some might be buying something, some might be browsing some items, some might be updating his profile, some might be recharging his wallet, something. But they are doing some operations they are performing in the application. Okay, so those are concurrent users. Now, when I say simultaneous user, all those users, all those 10 users, if they are simultaneous user, they'll be doing the same thing. That means when I say that okay, they are buying the product, that means all of them are clicking on the buy product. When I'm saying that they are selecting the merchandise, so all of them are typing at the same time. All whatever the actions that they are performing, they are performing, all of them are performing the same actions. Okay, but that is not the real case scenario. So mostly we always take concurrent users only. Okay, while designing a scenario, even when you configure in your controller all the scenarios, those are concurrent users only. There's a special case where we need to implement the interest users or simultaneous users that I will discuss is a part of our spike testing. There's one scenario that gets created, there we have to do something to implement this. Okay, so most 90-95% of the time it will be your concurrent users only. Okay. Now, if the user base increases more than 25 users, that means you have an application deployed all over across the globe. Okay. So as you know, for Amazon.com, if you can also see that Amazon.com, there's .com and there's .in. Okay, that in one in is global. Okay, that can be accessed from all over the world, and they have created something for Indian public also. Same goes for other regions as well. Okay, so that means the when we are hitting Amazon.com, my request is going to the nearest data center, which is it might be in India or nearby country only. Okay, so if there is an increase in the local user base 25 or across, like average users base count across each site has increased 10 10 10. Okay, so let's say you have deployed four site. That means you have a website deployed for India, then for China, then for Middle East, then there is for APAC, like that, and there is an increase of 10 users in each region. Then definitely you should go with performance testing for that applications. Okay, now operations of business. So let's say there are some in your application there are some features, okay, which is very very crucial to our business. Okay, if in any of these features, let's say the best example to understand is that if I'm buying a lift, okay, I have an application, a customer can come and buy the or leave it even you can think of amazon.com. If for some reason buying option, when I'm clicking on buy and I'm not able to go to the payment portal, okay, that is happening with Amazon. Imagine how much loss that they are going to handle. They can bear to have a downtime on their once the payment is done and all. They are saying that okay, the delivery will happen in 2 days. Okay, due to some internal glitch, they are not able to set up all the logistics. Okay, their internal employees is not able to set up the logistics. Okay, so there might from 2 days it went to 3 days, or let's say 5 days as well. That is still okay. I mean, they are getting the money because people are able to place the order. Okay, and they can resolve it in the meantime. They can like wrap it up, like speed up this process as well. But if somehow they are not able to place the order itself, then that's a very very crucial issue. Okay, they are having a business loss every hour or every minute, you can say. So again, business functional coverage is there, that should be tested, performance tested very very thoroughly. And then the revenue impact, any functionality in an application, if it is having a downtime or if it's not performing to the up to the level. Okay, that means when I say that okay, if there are 10 users on the application, they are able to place the order, everything is moving smoothly. Okay, but when the user calls are increased to 25 and they are expecting a traffic of 50 users, when they are having let's say when the 10 users are there on the application, they are placing the order, they are able to place the order within 5 seconds. Okay, but when there are 25 users on the application, the response time is going up to 15 seconds. Okay, now the user has to, now there's a product which is there for 20 rupees on both from Flipkart and Amazon. Why would I wait for 15 seconds? I will go and buy from there as well, right? So that is the cruciality of the, I mean, the task that they're performing. So revenue impact, any functionality which is having a revenue impact that needs to be thoroughly tested with performance testing. Okay, then the application high-availability of the need. So application which needs high-availability, same nature of the application which needs to be available. So the home page should be available. That should not happen that okay, when 10 users are there, I'm able to access the application. I'm able to browse a different item on the amazon.com. Everything is good. But the moment 25 users came on the application, my user experience becomes so bad that when I'm clicking on next item, it taking forever to load, or it's not loading properly. I mean, all the things that can happen, like it's not loading properly, speed is very slow, response time is very high. All those things are happening that needs to be tested for definitely. Then global access. So if any application which is there on a global level, okay, any, you cannot say that okay. When I say global, that means any website. If you're hitting that website and it is accessible all over the globe, that then that needs to be tested for home tested definitely. Okay, public usage. So high external user base. Again, same thing. High user count is that if it's that is there. Then architectural complexity. So complex computation. What do you mean by complex computation? If you look at a banking application, okay, you go and do internet banking, right? That the algorithm that has been defined is little bit complex over there. The workflow is little bit complex over there. Okay, so there is a possibility that the, okay, always remember that sometimes when the code is complex, when you're doing a functional testing, I mean, your test cases might pass. Okay, that can happen. Your test cases might pass, but under the load, it usually happens that the code behaves weirdly. Okay, so that needs to be tested thoroughly. Okay, if you're expecting that, okay, when the users will be live and accessing the application, you are expecting a traffic around 300 TPS, let's say. Okay, that means per second 300 transactions are happening. That level of traffic, if you are expecting. Okay, and you have done the sanity with like not even 1 tps. Okay, one, like let's say 1 tps you have done it. Okay, when you're doing a sanity, you are doing a test cases, you are done with one users and you have just checked all the flows. Okay, but in live you are having a 300x 300 times the traffic, when the users will be there, then how will your code will perform? And even the code that you have written, I mean, I'm talking about the developers, it's little bit complex. Okay, it's taking data from many components. When I say complex, let's say, you can understand this in a simpler way. You can look at the R application, MFS application architecture. Okay, so it's based on microservices. I will explain this in a further classes, no need to worry, you can just understand this. There are three microservices that you should be, let's say there are four microservices. Okay, so the input that this microservice is getting from API gateway, it is getting from Eureka. Okay, that is one microservice. Now, let's say that there are 60, 70 microservices. Okay, and this microservice take its input from 30 different microservices. Okay, it is taking this microservice. That means in order to process the data it is supposed to process, it needs to take input from three different microservices. Okay, and there's a load of thinner tps. Okay, so how the code will perform, nobody knows. Okay, nobody knows. So in order to, because the architecture is little bit complex, okay, then we should definitely go to the performance testing to identify how the code will perform under the given load. Now the heavy data computation. Okay, that, how do you mean a heavy data computation? That means what data are they processing? What data are they processing? Okay, mm, the simplest way to understand is that, if I am searching something, okay, there's a scenario in which I have to go on the application, I have to just search a product. Okay, it will what it will do, I will just write, let's say, boxes, and it will fetch me all the list of boxes whichever is there. Okay, now this is a very simple computation. I'm just sending one data. It might be on this application part, it will be writing a query to a database, it will be fetching all the details. Okay, but let's say if I'm saving the data of the customer. Okay, so there are customer inventory when the users are buying the application, buying the product basically. Okay, they have to give their name, address, card detail, the delivery address. Okay, and let's say, you can think about a mobile recharge also, in which expiry date will be there, the plan that they have bought. Okay, um, let's say there are three more fields that needs to fill in. I mean, depend how the application, I mean, the application team has developed the application. But the size, I mean, the data that I'm storing for one user is around 100 kb. Okay, 100 kb file is getting generated. Okay, this is data intensive. Okay, this is data intensive. Now this data will go and get stored in a database, and whenever I'm doing a search operation, this data will be pulled from a database and will be shown on the GUI. Okay, which is a data intensive process. Now how the database will respond to this? Okay, because large number of input output operations will happen, and handling of these files. Okay, and I mean, that depends upon the how you have designed your architecture. Okay, but whenever you are moving heavy files, you expect heavy computation on the on the database side. So is your database tuned properly or not? How do you get to know? You have to do a performance testing. Okay, then multiple jobs in the same thing. What you mean by this is that the multiple interface in jobs, that means multiple components are involved. Okay, when I say that, okay, this I have three components in my application. Simple way to understand is that I have three components in my application. Component first, I will give the input, it will process something, it will give the output to second component will process it and give the output to third component, and it will give me the final output. Okay, it's a very simple architecture. Okay, let's say I've designed some architecture in which there are n number, like, different, let's say 5 6 different components are there, and in order this final component to process and give me the output, it needs output from all these different components. Okay, it is taking the it is taking all this output, input from all these different components to give me the output. Okay, that means multiple interface and jobs are involved. Okay, then if you're doing the sanity with a single user load, if you're doing doing a functional testing, it might pass. Okay, the workflow has been defined properly, but what will happen if you test it under the load? How the application will perform, don't know. We don't know. As a first step, we cannot comment. We have to do the testing. We have to design a test. We have to execute a test to understand how the application performing. In order to do that, we need to do the performance testing. Okay. So these are the 5 ways which will help you to identify where performance testing needs to be done. Okay. And if any of these 5 scenarios are getting, I mean, are you able to identify any of these 5 scenarios? Definitely, you should go ahead and ask for performance testing. Okay. Any doubts, guys, in this one? Any doubts before I move forward? No doubts. Cool. Okay. So next thing is to understand what is the area of operations. That means as a performance tester, which is an area which you can analyze, optimize, or give recommendations. Okay, and which is the area where you can analyze and give suggestions that okay, that needs to be that can be done. These are the problems, and that will up to the customer to fix it. Okay, so we will see what are those things. Okay, first thing is your client machine. Okay, now let's say that from where you're generating traffic. Okay, so if you remember in our in the methodology, we have discussed that we have our performance center, or let's say controller, from which it is we are generating traffic through all these lgs, different lgs that I have. Now there's some issue with my lg. That means it's, I mean, the memory is 4 GB, let's say. Okay, and I'm generating some high traffic, high tps from these machines. Okay, now the machine itself has its own constraint. My this machine is very very fast. I mean it. So there are a lot of machines which itself is very slow. That means when I'm clicking on start, the browser itself is taking time to open. When then hitting the request will itself, that's a machine issue. Okay, because machine itself is slow. Okay, that's a client issue. Now is it same for every user? No. My machine is fast, your machine might be slow, right? So your user experience is different from mine. Okay, even the application is working fine for all the users whose machine is fine, but the user itself machine is slow, so they are having a bad experience. So am I responsible for that? No. So client machines, so whichever the client machine is there, so it if it's like if we're talking about the application which is internal in the like internal network. Okay, not exposed to the outside world. Let's say for Amazon, for logistic management, whatever the application that they use, that is not exposed to the outside world. I don't know what application that they use, but all the Amazon employees will be exposed, they are using that application. Okay, now for some reason the employee, one of the employees, his machine is poorly configured and it's very very slow, and he's complaining that okay, I'm not placed the order, it's taking me longer duration of time. Although all the other users are not having the impact. Okay, all the users are able to do it, there is no complaint from their end. Okay, that means that's a localized issue, and that's a client issue, and that needs to be investigated how the machine is been configured. Okay, so and if that is the issue, then we can definitely ask for a better configuration. I'll give you one very good example. So there was a time we were using Dynatrace. Okay, and there was a complaint, one of the application which is a globally accessible application. Okay, and there was a complaint every now and then, users are complaining that they are not able to access the application, or it's taking forever to load, it is getting timed out, all those errors, complaints that were getting escalated. Okay, so there are different kind of level actually. So P1, P2, P3, uh, P1 issues were getting raised for that. Okay, because a lot of users were complaining. So we had Dynatrace deployed on that environment, so we were able to investigate. Now what the outcome of that investigation was that, first what we did, we basically bifurcated all the users. Okay, so what in Dynatrace there's a thing called real user monitoring that has been enabled. Okay, so we have segregated, okay, which region users are having a a poor response time. Okay, so we have segregated that. Okay, it is coming from China region basically. Even if when we dig deeper, that all the users were there from Taiwan region. Okay, so users which are accessing the application from Taiwan, they were having a bad response time. Okay, okay, now then we have investigated why those users are having bad response time. Okay, obviously we know Taiwan, so there are a lot of constraint. Okay, there. So the browser that they were using, the internet browser, I mean the Google Chrome that they were using, that was very very old. Okay, 1.11 something. Okay, and there are certain policies that have been able to in order to protect the website. Okay, and the user, I mean the application was deployed on Azure. So there's a thing called corp policy. Now the corp policy was enabled to protect it from all, any malware or any attacks. Now the Chrome has not given any fix in that version. So what was happening that all the users, when they are trying to access the application, they were not fulfilling that policy checklist. Okay, and the server was not allowing them to go inside the server. Okay, so what were the, I mean, what are the recommendations? So we have identified all the users, and this was the case for all the users from Taiwan. Okay, so what we did, we gave two recommendations. First was that either you disable this policy, okay, which is like highly unlikely. Disable this core policy, so the current existing user with the current browser, they will be able to access the application. Okay, or you do one thing, you ask them to upgrade. So what we have seen that in the next version or the latest version of the Chrome, this issue was mitigated. So I mean, so all they need to do is to upgrade their browser and access the application. They will be able to access the application, the issue will not come up. So these are two recommendations that were that went from us. And later on, they decided with the second option. They asked the users to upgrade basically, and the issue got mitigated. Now this was a client issue, that was not a what do you call as a uh, I mean application side issue. But yeah, users were complaining. Overall user experience was getting hampered because as a part of your when you say response time, we are considering right from the moment we are hitting the request to the moment we are getting the response. Everything is getting captured. Everything is getting captured, and that is part of your response time. Okay, that is a part of your response time. So as a part, that's why analysis is very important. So we should be able to identify, okay, whether it's a client issue or not. If it's a client issue, what can be done from to improve that performance. So if it's like it's in the internal domain, okay, it's in the internal domain, then definitely we can improve and suggest something. If it's out external, we cannot do anything. That we will see in the end. Okay, but if it's internal, then definitely we can do all these operations. Okay, so first is client, next is network. Now again, this is your internal network. Think of an application which is deployed on an internal network. Okay, so when I'm accessing my any application, let's say if I'm in my office and I'm accessing my timesheet application. Okay, every organization has a timesheet, so we all fill our timesheets. That timesheet will not be so let's say if today you're working in TCS timesheet will not be accessible by Infosys employees, right? That is internal. Now if I'm not able to access the timesheet for some reason, so first of all I look at the client machine. Client is not okay. If it's a, then it can be a network issue as well. Okay, so network is internal network of any company is managed by the network team of that organization. Okay, so they can control what is the bandwidth, what is the traffic volume that is coming up, what is the net router configuration that has been done, priority of transactions. That means what operation that you're performing. If you are applying for a leave, or when you are applying when you are filling your timesheet, which which one should be given priority, like that. This configuration can be done on the network side. Okay, and then a network footprint. That means when I'm there's a thing called hop points. Okay, so I'll show you it. Now if you see what I'm doing basically, I'll tell you what is this traceset command is. As of now, just focus that when I'm hitting on this Isha Training Solution.com, my request is going from my machine, local machine, to the this Isha Training Solution. This is the IP of that machine. It is going to that location. Okay. Now it doesn't happen that okay, there's a point A, there's a point A, and there's a point B. When I'm hitting an request, it will go from point A to point B. No, it doesn't happen like that. Okay. Intermediate, there are a lot of points. Okay, there are a lot of hop points. That is what your internet does, internet provider does. It will provide you that hop. I mean that. So you can call it as a network. Okay, so in between the, so from your local LAN it will went to your WAN, from WAN it will go to the data center, from there through all the optical fibers it will go to the other continent if it's that is there, then from there from their data center it will go to their WAN, then LAN, and then it will go to that particular machine. Okay, so we call them as hop points. Okay, hop points, that means it is hopping from one point. So in order to go from my machine to the Isha training hardware, it will go for all these hop points from, and it has certain IPs. So this first of all will be my modem. Okay, then there will be local LAN, then WAN, like that it is there. Now it got timed out. So these IPs that you see now, I have a BSNL network. That's why it is going through a BSNL service. These are the hardware IPs of these machines. Okay, now why I'm showing this basically. Now, how you define this on a outside network, let's say if it's on the internet, we cannot control that. But if we are internal, if you are inside my internal app network of my office, okay, my network team can configure how or how many hub points should be there. So what they can do, let's say from my machine to the machine where the timesheet application is hosted, I have defined 10 hub points. Okay, and I've seen that these 10 hop points are taking longer duration of time. So is there any way we can reduce this? I can say instead of 10, let me have it only 5 hop points. Now the response time in order to now in order to go from my machine to the timesheet house will take a lesser duration of time. Okay, that is how we can reduce the hop point. So with the fourth point, network footprint, that the footprint that it is creating, this is the footprint, I mean it is going through all this machine, can we reduce this, can we reduce this? Yes, we can. Not we have to ask them, but a network team definitely can look into that. Okay, and reduce the footprint. Now if you reduce the footprint, obviously the overall response time will also improve. Now earlier it was going through 10 machines, now it will go through only 4 machines. So obviously the response time will be lesser. So the network part, in the thumb rule you have to remember that I discussed, it should in any given day, and in the peak load basically, the network utilization should not go beyond 50%. Okay, so if network is something which is internal network, then definitely we can analyze that. Okay, and improve. God, give me a 2 minutes. Okay. Next thing is server. Now this is your application server. Obviously we can look at the code when you're doing the testing. So we'll be, if we are seeing that okay, some issues, or the response time is getting higher, okay, or the sanity itself is failing at the high TPS, then definitely we can look into that using our APM tool. Not you, APM tool, through APM tool we'll be able to identify those issues. So we can ask for any code changes. Okay, so that is something that we can analyze and optimize. Okay, then the process and memory, that is something will be monitoring it during the run. When we are executing the test, we can see CPU memory utilization. If you are seeing they are going on a higher end, definitely we can ask for improvement on those point, ask them to optimize as per our need. Then local network done, then compression and all, you can think of it as improvement points only, performance improvement points. That depends upon how the system has been configured. If you are able to see any recommendations that we can do to improve the applications part of it, server part of it, then definitely we will go ahead and ask for that. So these are the areas that we can analyze and optimize. Next thing, database. So the program queries, so what queries that are getting fired, how application server and database server communicate through queries only. Your database only understand the queries, be it SQL query, no, I mean whatever, if it's no SQL, whatever kind of database that you have, it only understand queries. Okay, now what queries are getting fired? So if let's say you are saying select from where id is equal to 5. Okay, so it's just select from where table name will be there. Okay, and where id is for, so in that table there is a column called id. It is just fetching that id, and you have done indexing. Okay, and so all the ids are arranged in a let's say order, in a ascending or descending order. It is, the query will be faster. Let's say you have your here you have done where by or sorry, order by where clause. You have like increased the query length. You are doing multiple operation in a single query. Obviously the response time in order to execute this query will be higher than the basic query. And now, so as a performance tester, what can you do, so obviously you will be, if you're seeing that all the calls when you are doing the testing will be monitoring the database calls that are getting fired. Okay, and if you are able to see that okay, all the database calls queries are taking high response time. Okay, so we know that any query should not take more than, like if you have seen, this queries are in 0.001 seconds. Okay, okay, now you're seeing that okay, the query is going beyond zero point 0.1 seconds or 1 second also, then that's a issue. And if that is the case for all the queries, then definitely it's a issue. So you have to ask the dba expert. You need a good dba expert on this one. Okay, and you have to ask them that this is how it is, this is how we are seeing the performance is getting rigged. You have to tune their query, you have to change the query so that it becomes little bit faster, so that they will do the changes as per the need. So they have to look into that what are the data that they have to fetch, and what is the best way, and the simplest way they can fetch that query. Then the db architecture, how your db has been configured, whether it's been configured correctly or not. What is your requirement, what kind of operations are you performing. Okay, let's say you are doing search operation, you are, so uh, you need you need to store some data. Let's say you need to store some data. There are different type of database. Okay, you will understand this in the subsequent classes. There are a lot of simple different kind of database as per the requirement. So there is one database called elasticsearch. Okay, there is a database called sql, there is a database called NoSQL. Okay, all those things are there. Now people who quickly, I will tell what is this elasticsearch is. Elasticsearch is, it's a basically a database which is which store a large amount of data. Okay, and the queries are very faster in this one. Okay, so let's say you are storing the data of the customer. Okay, customer wants to check how much balance I have, or what is let's say I have to check balance, what is my balance. That can happen, right? So they don't want that okay, when I'm checking a balance it's taking forever to load. So what I've done, I have created a different database altogether. Okay, in which I'm just storing the customer name, their id, and their database, their balances. Okay, and have a different database basically, which storing all the details like that. Now how do you take that call? I mean, as a performance tester, you can obviously, when you're working on the project, when you're understanding the technology, you will be able to take all those calls. But you have to, as a part of your architecture, how our database has been defined, what is the reason. So you have to ask that okay, I can see you have three different database in architecture. That can happen, that one they have elasticsearch, then they have sql, they have postgres. Let's say different kind of database are there, they have employed. So you have to ask them that what is the reason for that. Do some analysis on your end also, whether it's improving the, so they will tell okay fine, we have installed elasticsearch because it's faster, and this is the reason we are storing the customer balances in this database, and it should be faster. So you can ask them okay, what is the response time, how much time are you expecting that when a customer fires a query, within how much time you should get the response. So they tell 0.011 second. So while doing the testing, you have to be watchful around those things. Say if you're seeing if it's going higher, then definitely you have to highlight that. So how the architecture, I mean db architecture, that's what we are trying to say, that how and why the database has been configured. Okay, and are they fulfilling their responsibility or not. Okay, so as a part of engineering, you should be watchful for that. Okay, then indexing and maintenance. So indexing needs to be done properly. Okay, indexing is just like you can think of as your book index. Okay, if there is no index in your book, if I just tear out that page, and if I ask you, can you open that chapter? So what you will do, you will keep turning one page, second page, third page. Maybe you will reach the page chapter that I'm asking. It's on the 100th page. So you have to like check all the 100 pages, like until 100th page. You have to check all the pages which is there in between. Okay, but I have an index. If I have an index, I can just see the index page. Okay, this is a chapter that you are asking. It will start from the page number 100. I will directly go to that page number 100. Something similar is indexing only. Okay, so when you do indexing, your queries will immediately know, okay, I need to go to this particular index, and they will go. So it's become very very faster. So and this needs to be done properly also. How indexing is done, that is also very crucial. Okay, so that is there. So if you are seeing all these issues, we can analyze this issue using APM tool. Okay, and optimize. That means we can give them recommendations that we are seeing these issues. Okay, if you have the access, definitely, if it's an environment which is under your control, you can definitely go ahead and do the changes. And if it helps, then you can share those findings with the application database team, whosoever. If you don't have the access, you have to involve the right team and get it done, get it fixed. Okay, but this is area which we can analyze and optimize. Next two areas are basically areas which we cannot optimize. Okay, so let's say for Isha, let's say if there is network issue from my end. Okay, when I'm clicking on ishatrainingsolution.com, in between the network my request is getting lost, or it is in high response time. Okay, due to some URL, I mean whatever, I mean it can be gateway capacity. Let's say my network, somebody is doing downloading. Okay, heavy downloading they are doing, a lot of people are doing heavy downloading. Obviously the bandwidth will get choked up. Okay, there is nothing that I can do. I cannot ask them to stop the downloading, because I don't know. Maybe my network provider, but the network provider will also not stop them. He can increase the bandwidth, but again that will incur him the extra cost which he doesn't want to. So it is like that. There's nothing that I can do. But as a part of analysis, I could analyze that okay, there's a network chokeness is there. Because of that, my performance is getting degraded, but there's nothing that I can improve. Okay, so this is area which we can analyze. Okay, as far as optimization is concerned, we don't have the authority. Same goes for the external users. So let's say my machine is having some issue. I'm getting a low traffic from my from this machine. This machine itself is slow. Okay, then I'm claiming that okay, the response times are poor. So that is not something that happened from the application point of view. Let's say you can think of that example that I gave for the users that are from Taiwan. Let's say users decided no, we will not upgrade, or their government is not allowing to upgrade. Some issues there. Will their performance improve? No, there will not be improvement. But as a part of analysis, we know what is the issue, why they are having those issues. So these are the different layers which you will encounter in your part of performance testing. And this is how you will like approach them in terms of analysis and optimization. I hope it's clear. Clear, guys? Give me a yes or no so that I can move forward.
Yeah, it's
Okay, cool. Next slide, I expect people to know. Okay, so although it's written also, can anybody tell me on a high level what is load testing, stress testing, endurance testing, spike testing, volumetric testing? Come on, quickly, guys.
Yeah, so load testing is like, for example, our website or application is designed for 10 users. So load testing is we'll test it for 10 users only, like the expected one,
Mhm.
expected load. Stress testing is like we are increasing the expected load. Instead of 10, we are testing it for 15 users. We can say it as like we consider the future perspective as well, like
Mhm.
increasing the load from the expected one. And then endurance is like we are testing the application for longer duration. For example, instead of 1 hour, we test it for 8 hours. Generally it's 8 hours. Sometimes it's 12 hours as well, sometimes it's 24 hours as well. Spike testing is like it's like kind of spike itself, like we are increasing the number of users or load and then decreasing it, then ramp up, ramp down, so it kind of like spike. Volume testing is generally from database side, like we are hitting the application with large number of data, or for example we are updating a huge set of data in our test. So
Okay,
that's volume testing.
okay. Yeah, I mean, it's correct only. Let's go with them through examples so that we understand in a much better way. Okay. So whatever the Manisha has said, these are correct definitions. But we'll go it again. Now, What is load testing? Simply put, load testing is a type of testing which involves vetting the performance of the system under the expected load. Okay, so for any performance tester, load test is a basic test. Okay, it's like when you go to hospital, the doctor will ask you, sit, I will check your BP. Okay, they will rate you. That is how you should be. Okay, the first step you need to execute is load test, because first we need to understand that the current configuration, the application that has been deployed or the configured, or they are in process of making it, they are saying that okay, I'm expecting a low traffic of 10 users. The current website, current configuration should is it able to hold this configuration as well or not? First thing we have to check that. I mean, all these tests will come after that, but the first test we need to check whether the current the configuration that for which they are working on it is that stable or not. Okay, so we have to do a load test. We have to just work with the expected workload that has been given to us, whatever it may be, how they have designed it. Let's say 100 user, 200, whatever the configuration that they're expecting, you have to test with that given configuration. Okay, a typical load test include determining obviously the response time, throughput, error during the current course of the load test. Okay, this is a basic test. So if you look at the graph, you can remember like this also. So you have a anticipated load, let's say this many, these are the v users. Okay, so you are expecting these many v users, so you will ramp up. Okay, you will hold for 1 hour of duration and then you will ramp down. Simple. Okay, now another type of test is a stress test. Okay, stress test is a type of performance testing where we evaluate the application performance at the load much higher than the expected load. Okay, now you can call it as a scalability test also. Okay, why do we employ this? Let's say I cannot afford to have a performance testing done every quarter, something like that. But I'm expecting that in my application, my business looks good, my numbers look good. Okay, so I'm expecting that okay, within let's say within 6 months, my user base will increase from 100 to 150. Okay, they're expecting that that can happen. Okay, now do I need to how will the users will perform? Will the application will be same? I mean the metrics or the SLAs that we have discussed, those SLAs will remain the same when we have 150 users? Yes or no? Obviously, we as a pharmacist, until unless we have not tested it, we cannot comment. Okay, so they'll be asking, can you can you comment on this? So we have to tell them that okay, so we have to do the performance testing first of all. Okay, next thing is that they have to decide that okay, whether these many users are going to come and will they be doing all this process over again and again. So what people usually do, what a client usually does, if they expect this kind of behavior as a part of their existing testing, they include one extra skill test, or we will call stress test. Okay, and so that they will know what is the behavior. They know okay, if the 150 users will come, my application is will behave in this particular way. Okay, then it will be their call to upgrade, so that they should not face this issue, or leave it there itself. That okay, fine, we are anticipating this. If this comes up, then only we'll upgrade, otherwise we will leave it as of now. Okay, there's one more point to this, is your breakpoint. Okay, in this one, so let's understand from the graph. Okay, so if you look at the graph, in our load test, we had a certain load. Okay, we did a ramp up, then we basically kept it steady state for that 1 hour for duration, and then we ramped down. Okay, in your stress test, we have a higher load. So if this is x, this will be 1.5x. Okay, and again we kept it steady for 1 hour, and then we have ramped down. Okay, there is only difference, the load basically increases, usually it's 150%. Okay, now in this one only, let's say you what usually does happens is that when you have done the stress test for 1 hour, you don't ramp down. Basically, you don't ramp down. After that only, uh people, you can run a standalone breakpoint test also. I'm not saying that you should not run a standalone breakpoint test, but yeah, we know that okay, we have done a ramp up, we have kept it steady for 1 hour, so we got all the findings that we need for our stress test. But people, usually what happens is that they proceed with the further testing, which is your breakpoint, to know where the system will break itself. Okay, so what they do, instead of ramping it down, just keep on ramping the user until the system breaks. So how do you define how system will break? Simple thing is that you have all the SLAs that you have in your NFR, right? So in my NFR I have all these things defined. Okay, yeah, there you go. We have like failure rate should not go beyond 3%, or the response time should be below 5 seconds, or the transition, okay, this we can ignore as of now. The CPM rate should not go beyond 60%, memory rate should not go beyond 10%, like that. If if all of these KPIs break, let's say failure started coming up, okay, then but the CP relation is still some means it's not reached its limit, okay, until obviously if the 100% failure is that means that means my break point, okay. But if all the SLAs break, if all the SLAs break, that means whatever the threshold that we have decided, it has gone beyond that, that point we will consider as a break point, and we have to mark it as that, okay, after this point nothing, no request will get processed from the system, okay. Even if the single request is getting processed, we will not consider as breakpoint. Breakpoint is point where nothing gets processed, not even a single request get processed from your system, that is a breakpoint, okay. So as a part of our breakpoint, so another aspect of stress testing is to determine the breakpoint of the application, the point which application fails to respond to correct manner. Okay. Now next thing is endurance testing. Endurance testing is done on the application which has that nature. The best example to understand is your salary processing application. Okay. On the 30th, for let's say TCS has 30 lakh employees. Okay. Or everybody's salary is getting processed on 31st. Okay. Now imagine the salary, like whatever the application that they have developed in order to process all these 30 lakh salaries, okay, that will be processing in that application. That means that application will be in use for an extended period of time. That means that if you once it start processing the application one by one, it will keep on processing for let's say 8 hours, 12 hours, I mean however they have designed. That is the nature of the application, that it is getting used continuously for a longer duration of time. Okay, so when a client will ask you that, okay, can you do endurance testing, you have to ask them, always ask them. I mean, when load test, obviously it's like that is understandable that, okay, fine, we need to do a load test. But yeah, when you are doing a stress testing, you have to ask them, why do you need to do test testing? If it's meeting all the criteria, I mean if it's give a logic or to behind doing the testing, then definitely you should do that testing. Okay, when you're doing the endurance testing, you have to ask them, it is the nature of the application. It is what is this, you are saying that, okay, I need to do a soak testing, but are you expecting that, okay, for let's say 5 hours, 6 hours continuously application will be engaged? Is this what you are expecting in production? Okay, is that is the nature of the application? If yes, then ask them to do the testing. Otherwise, there is no point if that is not the nature of the application. If the single user session is not more than 5 minutes, 10 minutes, okay, and it's not getting used for extended period of time, then there is no point doing that endurance testing. But if that is the nature, if it's such that, okay, the users the application will get used for extended period of time, definitely we should go ahead and do the endurance testing. Okay. And the another aspect of endurance testing is to find the memory leaks. Why memory leaks? Because you will see that whenever the application is getting used for an extended period of time, continuously processes are going into a memory for processing. Okay, memory heap memory is getting new program is coming every minute. So how your memory management is happening, that's become very very crucial. Okay. And if the memory management has not done properly, if the codes are not written properly, okay, or the memory management configuration that you have given it's not done properly, you will definitely have out of memory errors. And I mean, if you have out of memory errors, obviously your transaction will fail. If there is no memory your heap, nothing will get processed, right? So you will start having out of memory errors. So the biggest challenge that you have with this kind of application which is getting used for an extended period of time, you have to work on, you have to be very very cautious on the memory management. Okay. And developers okay, they are very very careful while working on this application, and they are obviously watchful for this. But how do you test it? Okay, they cannot put that much amount of load, they cannot put 3,000 4,000 users, but as a performance testing team, we can do that, we have the feasibility to do that. And we will be able to tell, okay, under the peak load, we will be able to simulate the same scenario. So if there is any issue which is missed out, we will be able to find out. So mainly address testing is done to find out all these memory leaks. Okay, now next is spike testing. So if you look at the graph also looks like the same. Again, we have a certain user, we'll be running for an extended period of time. All these other tests what you see here is for 1 hour. Stress test is also for 1 hour, load test is also for 1 hour, spec testing is also for 1 hour, but endurance testing is minimum 5 to 12 hours. It can go for 24 hours also. Okay, but how do you come to this number? Simple, you have to ask them what is the case in production. Are you expecting this in production? Are you, when they say do for 24 hours, are you expecting 24 hours of traffic in the production? If yes, then you should go ahead. If they are expecting only 5 hours, then why should you do for 24 hours? Okay, so you have to ask the customer that, okay, are they expecting this or not? If yes, definitely. If they're expecting, then we have to do it. Otherwise, if not, we don't need to do that. Okay, this is for the endurance testing. Spike testing, the best example to understand spike testing is Amazon Fire Day, I think. That's what they call it, right? Prime Day something, yeah, in Amazon Prime Day, yeah, Prime Day. So what will happen that they will say that at 12 noon, okay, they will open some offer. So some mobile is getting sold, I think. There was a Fire Day sale, I think, on Flipkart, yeah, they sold very cheaper. They sold for 30K only. Some iPhone was getting sold. Later on they withdraw their offer. So when the news got out that, okay, there people are the iPhone will be getting sold for so cheap. Okay, although the users who are there on Amazon, okay, are like 30K, 30K users are there. Okay, now this news got out and suddenly everybody wants to buy that. So at noon, all, let's say 1 lakh user came to buy that product. Okay, let's say 30%, let's say 30, some whatever number the inventory were there, that inventory got sold out. After that, all the rest user, they was getting out of stock error. So they again, I mean, they obviously they will not be checking other items. They came to buy iPhone and they will go back. Okay, again some offer will come up next time, and all the users will new users basically who know, okay, at 3 there will be this offer will be coming, I have to log in at that time, I have to buy the product. So all the users will be coming up. Okay, and then they will buying the product. And if some got it, some didn't get, but the traffic will go after some time. Okay, and again certain users. So these are the, when I say certain users, that means it's not that Amazon is, this is a new user that they're getting because of the sale, but there are regular users which are basically with regular traffic, not the user, regular traffic that they're expecting. Okay, on average we are seeing 30K users accessing the application, buying different products all across the website. Okay, different merchandise they are buying. But due to this fire sale, sudden increase in the users is coming up. Okay, if you have, if this is the nature of the application you have in your, I mean, for which you are doing the testing, you have to do a spike testing. This is what spike testing is. That there is a certain load, suddenly something will happen and all the users will, there is a sudden increase in the user, and after some time they will go away. Then again the application will remain steady for some time, and again there will a sudden increase in the user, again it will go away, and this will keep on happening. Okay, if you have this nature, this I mean, you have this nature, this kind of nature in your application, then definitely you have to do a spike testing. Okay, why spike testing is very very crucial in this? Because if if you are seeing that, okay, if these users are coming at these users like this much sudden increase is there, what if the application crashes? What if the response time get degraded for all those first 30 users who can buy the product also? What will happen? Obviously it's a bad customer experience, right? It's a bad customer experience, so which you don't want that. So in order to mitigate that and in order to identify that error, we need to do a performance testing. Okay, we have to do a spike testing, sorry. Okay, but how do you design this scenario? How do you achieve this? Basically my question is that, anyone? There is one function that we need to use. So this is what, when I say interest users, I was talking about concurrent users, right? So when I'm saying steady state, all these users, let's say these are 30 users. These 30 users are doing something on the application, they are not doing the same thing, but at this point of time, let's say if these are 20 users, all these 20 users all want to buy that product. All these 20, 30 users, let's say all these users 30 users want to buy the product. That means these are interesting issues. They are, all of them are clicking on buy now. All of them are clicking on buy now. Okay, they are, every user which is there, they are doing the same task, these users at this point of time. So how do you achieve that? There's a function called LR rendezvous point. Heard of it before?
No.
Okay, so
Yeah.
there's a function called LR rendezvous point. What it does, we have to, like, you record your script regularly, okay, and then you define that function LR rendezvous. Okay, what will happen that first user will get ramp up, it will do all the transactions, it will come to this LR rendezvous, it will wait. Second user will get ramped up, it will do all the transaction above that, it will come up, it will wait. Let's say there are like 30 users, like this there are 30 users, all these users will get ramped up, it will do some transaction which is above this, I mean LR rendezvous I have defined in middle, let's say. Okay, all the transaction which is above this, they will perform all the transactions. Okay, and it will come till the last user will come up. So the 30th user ramped up, it did all this transaction, and all the rest 29 users are waiting here. The moment 30th user will come, the moment 30th user will come, all these 30 users will immediately hit the next request after this. The rendezvous point that you have defined. After that, whatever be the request, all of them will hit the request 30 users at that same time. Okay, so this is how we achieve. So I mean basically the buy now, let's say in your script there is a request which is basically doing the function called buy now. Okay, so you will define a rendezvous point before that, and you will give the number of users. So at that point, when buy now will happen, whenever buy now will happen, all the users will come up, wait, and at the time where they need to buy the product, immediately all the users, let's say 30 users will release, all of the 30 users will click on buy now. Okay, so you will be able to see, okay, some traffic is there, and suddenly there is spark increase in the users, okay, for that request, and it will go down. Like that we design a scenario for spike testing. Okay. Okay, next is volumetric testing. We already discussed volume testing. Basically when we are doing the testing of the application, there is not much data on the database. Okay, so the queries that are getting fired from my application, let's say if I'm fetching some data of fetching some data of the customer, there are some 10 entries only. Okay, obviously the response time will be lesser. Okay, it may be X. But what if my database become 10 million now? Okay, now what will happen? Will it be same, will it be increase, will it decrease? I don't know. We have to do a performance testing, I mean we have to do a volumetric testing to understand how the system will behave. Okay, and how the query. So even if let's say you have written a very big query, very complex query, okay, you have written a very complex query. Obviously the entries are 10. No matter how complex you write, it will not take much time. But when you are firing a query on a 10 million data set, your query will become very very crucial. What kind of query are you firing? So that time all those issues will pop up, and we have to identify them beforehand. Okay, so volume testing is performed by feeding the application with the high volume data. The application can be tested with a large amount of data in certain database by providing large files to the application for the processing. Using volume testing, we can identify the bottleneck application with obviously. So the point is simple, that we are putting some dummy data into the database. Okay, and which will happen after a year. After 1 year, this much amount of data will get collected. Okay, when the application is live, this much data will get by the end of the first year. I can expect for 1 million of data in my database. Okay, so the user performance will decrease or not, what will happen? In order to find those issues, or to be certain that okay there will be no issues, we have to do a volume testing to understand that. Okay, so these are the okay, these are the five type of testing which is getting executed a lot. Okay, in performance testing. Okay, we'll be doing a load test, we'll be doing a silver test, and then we'll be doing a endurance test in our project. Okay, to understand them in clarity. Okay, so tomorrow we will start with NFR. We will understand what is NFR, what are the details that we need to capture as a part of NFR, and what are the things that must be documented, and what are the mandatory things, what are the things which we can still like leave and leave it as of now and move forward, so that let's say I need some 10 data. Okay, 10 I have a checklist in which I need 10 data set in order to execute my project. Okay, do I need all these 10 data to proceed further? Yes and no. So we will understand what are those points, and who are the stakeholders, and all those things we will discuss tomorrow. Okay. Any doubts in whatever we have discussed till now? Any doubts in the walkthrough anywhere? So in any project there are two scenarios. Okay. So and then we have understood what is person life cycle, who are the stakeholders, what are the what goes into each of the steps. Okay, then we have looked at the process. What is the process that we'll be following in order to execute our project? What is the methodology, how we are actually executing the all this traffic that we are trying to create, how exactly we are doing. Then what are the trigger points for performance testing? We have quantified that what are the performance testing criteria that if you identify, you can obviously recommend for performance testing. Which other area are there as a performance test which you can analyze and optimize, and which area we can only analyze. Different kind of testing. Simple. I think it's not that hard. Any doubts? Stop sharing right here. Manisha and Srinivas, any doubts?
I'm good.
Okay, fine. Srinivas, you have any doubt?
No, I'm good.
Okay, fine, guys. Okay, then let's meet tomorrow. We'll
Thank you.
start with an. Yeah, bye.